Hello students, let's continue with MCQs. In this module, we'll go for MCQs on finding time and time period. So let's start with our first question. The displacement of a particle executing SHM is given by x is equal to 2 cos pi t centimeter. The time at which the maximum speed first occurs is, and 4 options are given. That means I have to find time, that is small t, at which the maximum speed first occurs. In order to find first occurs, first I should know where is the position of the particle at t is equal to 0. Also students, we know speed is maximum at mean position. So let's see where did the particle start its motion from. So let's begin with the given equation, which is x is equal to 2 cos pi t. Students, I can write sin pi by 2 plus theta is cos theta. We know from trigonometry. Therefore, x is equal to 2 cos pi t. That cos pi t can be written as actually pi t plus pi by 2, where I have taken the help of this trigonometric formula. Students, if I compare this with the standard equation, x is equal to a sin omega t plus alpha, so we come to know that initial phase alpha is equal to, yes, pi by 2 radian. Also comparing amplitude, I can get amplitude is 2 centimeter, and students, omega is equal to pi radian per second. Students, let's focus our attention on the value of alpha. Alpha is pi by 2 indicates that yes, the particle starts from positive extreme. That means at t is equal to 0, the particle is at positive extreme. Let's visualize it. So let's consider a straight line path, and we know just now the particle is at positive extreme. Student, this can be intelligently done directly also by, if you look at the equation x is equal to 2 cos pi t, we know since cos is given, that means particle has to be at positive extreme. From our earlier modules, I have already taught you this. Therefore, now we come to know at t is equal to 0, the particle is at say positive extreme, and the question says I have to find the time at which the maximum speed first occurs. You can very clearly see maximum speed always occurs at mean position. Therefore, if the particle is at positive extreme, now it reaches at positive extreme. It reaches at mean position. So actually, I have to calculate the time taken by the particle to travel from positive extreme to mean position. Students, if you remember, this is nothing but 1/4 of oscillation, and hence the required time is actually t by 4 seconds. So in this problem, I have to only calculate t by 4. So let's find t first. As we know, t is 2 pi by omega, and I have already calculated the value of omega as pi. Let's cancel pi, and students, therefore t is equal to 2 seconds. Therefore, for this problem, our required time is t by 4. Let's substitute the value of t as 2, and hence it will become 2 by 4, which will ultimately become half. Since our options are expressed in decimal form, therefore half is nothing but 0.5 seconds. That is nothing but option, yes, option A. Therefore, the right answer for this problem is 0.5 seconds. Let's move on to the next MCQ, students. Body is executing SHM when the displacement from the mean position are 4 centimeter and 5 centimeter. The corresponding velocities of the body are 10 centimeters per second and 8 centimeters per second respectively. The time period of the oscillation is, and 4 options are given to us. So we have to find capital T. Students, very clearly I can see some displacements 4 and 5 centimeter are given to us. That is x1 and x2 are given, and corresponding velocities v1 and v2 are given. In the earlier modules for numericals, we have already derived a formula for this. So let me write that formula. So whenever x1 and x2 and the corresponding velocities v1 and v2 are given, the time period t is equal to 2 pi, yes, root of x2 square minus x1 square upon v1 square minus v2 square. Students, you can also write 2 pi root of, instead of x2 square minus x1 square, I can always start with x1 square minus x2 square, but then the denominator will become v2 square minus v1 square. Sir, how do you choose to which value first, whether x1 or x2? Always look at the given. For example, here x1 is 4 and x2 is 5. So x2 is greater. So let's start with, therefore I have started here with x2 square minus x1 square. If x1 is greater, you can go for x1 square minus x2 square, but then the denominator will become, if the first term is x1, then denominator will become v2. So let's substitute the values here. So I will write here as t is 2 pi. We can very clearly see x2 is 5, so this becomes 5 square, x1 is 4, therefore the next term minus 4 square upon v1 is 10, hence 10 square minus 8 square. So the next step, t is equal to 2 pi, 5 square is 25, 4 square is 16, and hence becomes root of 25 minus 16 upon 100 minus 64. Students, we know 25 minus 16 will be 9 and 100 minus 64 is 36. Therefore, the next step, root of 9 upon 36. 9 4s are 36 and hence the next step becomes t is equal to 2 pi into root 1 by 4 is half. Let's cancel 2 and hence the answer is t is equal to pi second, that is nothing but our option A. Students, so if x1, x2, v1, v2 are given, this formula is very shortcut formula and can be used for fast calculation. That's all in this module, students. See you in the next module.